Welcome. This video is an introduction to the basics of counting. By the end of the lesson, students will be expected to apply the product, sum, subtraction, and division rule. Let's begin with a warm-up. Alan, Beth, Dolores, James, Marisol, Christina, and Rita enter the waiting room at their dentist office at the exact same time. Now, they need to form a line to check in. And had they all walked in at different times, it would be very clear who was first, who was second, who was third, and so on. But since they all walked in at the exact same time, they're going to choose how they line up. How many different ways can they form a line at the front desk? So there are 7 people total. That means there are 7 possible positions in line. Here's the first position for the first person. And here's the 7th position for the 7th person. How many ways can we choose who will be first in line? Well, if there are 0 people in line, then we have 1, 2, 3, 4, 5, 6, 7 people to choose from. Say Dolores is first in line. Suddenly I now have only 1, 2, 3, 4, 5, 6 people to choose from. And this continues until the 7th person in line, and we can multiply all of these together to get 5,040. So there are 5,040 ways for these 7 people to form a line. And this is the number of ways to, this is a permutation of n distinct objects. And clearly in this, order matters. Next, what if the receptionist tells these 7 people that only 3 of them will be seen that day? Since only 3 of them will be seen that day, 4 of them have to leave. How many different ways can a line of 3 be formed with 7 patients in this waiting room? Well, now instead of having all 7 positions, we're only going to have these first 3 positions. So this becomes 7 times 6 times 5, which is 210. So there are 210 ways for 7 people to form a line of 3. What we have just counted in this second part is the number of ways to order our things, and again, position matters, so order matters, out of n distinct objects, where the objects in this case are the 7 people waiting. The notation for this is NPR, and this stands for n factorial over n minus r factorial, and you just unknowingly use that since this is 7p3, so this is 7 factorial over 7 minus 3 factorial, so this becomes 7 times 6 times 5 times 4 times 3 times 2 times 1, and I'm going to scooch this over for space. And this whole thing divided by 7 minus 3 is 4, so this is 4 factorial at the bottom. And if you notice, these will all divide to 1, so we end up with what we had here, which is just 7 times 6 times 5. And here, when I say a right order matters, the way we order in this line does matter. The person at the dental office who gets the first slot will be seen first, the next person second, the third person last, so they might be in there all day, whereas this person might just be in for a quick visit, so definitely order matters in this situation. Now to finish up our warm-up, let's suppose Beth leaves the dental office first. She realized she was not going to be one of the 3 patients to be seen by the dentist that day and decided not to bother with lining up. So she can leave the dental office traveling north along 2 different roads, or she can leave the dental office going south along any of 7 roads. And how many ways can Beth leave the dental office? So here's the dental office. And here are the possible routes. She can go north in 2 ways, and just to get our bearings, this is north, here's south. And Beth can leave south 7 ways. 1, 2, 3, 4, 5, 6, and 7. If she goes this route, this will have no effect on the other routes. And in fact, she won't even need to use those routes. If she goes this route, she's left all these other routes unused. So the key here is that any decision we make, or that Beth makes in this case to leave the office, any previous decisions do not have an effect on her current decision. So the total number of ways to leave the dental office is 2 plus 7 equals 9. Now what you have just been doing in this warm-up, you've been using the product rule and the sum rule without actually knowing what you were doing. So let's read and define these two rules. Suppose a procedure can be broken down into a sequence of two tasks, task A and task B, if there are A ways to complete task A. And for each of these ways of doing task A, there are B ways to do task B. That means there's a total of A times B ways to do the procedure. And this is the product rule. Next, the sum rule. If a procedure can be done in either A ways or in either of B ways, and none of the set of A ways is the same as any of the set of B ways, then there are just A plus B ways to do the task. So as you can see, you used the product rule for the first two parts of the warm-up. You used the sum rule for this last part of the warm-up above.